Okay, so here's a shout out for my 8-9 class. You guys are awesome. I couldn't find a better way to end my day. And honestly, I wish we had chemistry every day. I miss seeing you guys on D-Days. You're doing a great job with this unit. Bonding is one of the more difficult units. And I really like the fact that everyone's working hard and trying to get it done. So let's continue. Last lesson we talked about how to name and write chemical formulas of ionic compounds, and in this lesson we are going to talk about how to name and write chemical formulas of covalent compounds. Remember that IUPAC means International Union of Pure and Applied Chemistry, and it simply means what are the rules? How have I taught you how to name and write compounds? Recall that covalent equals a nonmetal and a nonmetal, or two nonmetals. Remember that also that you might see the word molecular, and we are going to use molecular and covalent synonymously. I also spoke to you about a binary compound, and we talked about ionic compounds. Binary means two elements bonded together, and ternary means three elements bonded together, but it could be more than three too. The procedure for naming covalent compounds is very similar to the procedure for naming ionic compounds. The only difference is, however, is that we are going to use subscripts. Yes. To designate how many of each element you have in a covalent compound. And the prefixes that we are going to use are mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7. I've never seen the Regents or any Regents books use septa. Octo for 8, nona for 9, and deca for 10. Again, most of the time on the Regents you usually don't see anything past 5. One exception that's really important is that we drop the mono prefix if there is only one atom of the first element. One atom of the first element. Final O's or A's of a prefix are dropped when an element begins with a vowel. So here, mono is 1, but we're not going to say monoxide. So we drop one of the O's and it becomes monoxide. So this would be mono is the prefix, and then we have oxide. So we're going to drop one of these O's, link those together, and just make it monoxide. All right, rules for chemical formulas of covalent compounds, other than the two that we just went over. The least electronegative element is written first, and the most electronegative element is written last. So if you have a question about this, you would use table S, look up the electronegativity of the two elements. So here, if you look at carbon and oxygen, carbon has a smaller electronegativity value than oxygen. So it's least electronegative, it's written first. Oxygen has more electronegativity, so it's written second. And lastly, the subscripts tell you the prefix of each element in the formula. So this 2 right here that you see, that is what we refer to as a subscript. And that 2 tells us that we're using the prefix di. There's only one carbon, and because there's only one and it's the first element, we just name it carbon, and that 2 tells us there's 2, so we use the prefix di, and then this is a mistake, that shouldn't be an I there, it should just be dioxide. There we go. And we name the ending, oops, there we go. We name the ending of it like we would the ionic compound. So let's do some examples. This is carbon, and there's 1, but we don't name mono for the first one. And this is oxide, but there's 1, so it's going to be carbon monoxide. We're going to drop one of the O's because we can't say monoxide. We just did this one. This is carbon dioxide. Now, here I have 2 nitrogens, so I'm going to use the prefix di, so it's going to be dinitrogen. I only have 1 O, so it's going to be monoxide. Here I have 2 nitrogens again, so it's going to be dinitrogen. Now the prefix for 5 is penta, but penta ends in a vowel, and oxygen starts with an O, so we're going to get rid of that, and we're going to just go with pentoxide. I'm going to drop that. We're going to drop the A. Okay, and the next one, we have carbon, and we have 4 chlorines, so the prefix for 4 is tetra, and then we just add the chloride. And in the last one, we have sulfur, and there's 6, so the prefix for 6 is hexa, and fluorine turns to fluoride. Not so bad, right? Told you I'd have you naming and writing compounds before the end of this unit, and you all laughed at me. Okay, so what is nitrogen? Nitrogen is N. Mono means 1. Oxide means oxygen. So 1 oxygen. So it's just NO. That's nitrogen monoxide. Carbon is C. Tetra tells us there's 4. Fluoride is fluorines. So there's 4 fluorines. C, F, and then a 4. This tells us there's 4 fluorines. Bromine is Br. Penta is 5. Chloride, so 5 chlorines. Cl5, 5 chlorines. Di is 2, nitrogen. So I've got 2 nitrogens, so it's N2, 2 nitrogens. Penta is 5. Sulfide comes from sulfur, N2S5. Sulfur is S. Tetra is 4. Bromine is Br, and there's 4 of them. And that's about it for naming and writing covalent compounds. We are going to review something though. We did this several days ago, but I didn't want us to forget it, so I did some layering and I taught you ahead of time. So we're going to review Lewis dot diagrams for ionic compounds. So it gives us a picture of the compound. It shows us the arrangement of the atoms in the compound. Within ionic compounds, there is a transfer or donation of electrons from the metal to the nonmetal. So the first thing we're going to do is draw the elements of the given compound and their individual Lewis dot diagrams. So Na's got 1. And Cl has 7. So those are just my valence electrons. Then I'm going to draw the electrons going from the metal to the nonmetal. And remember, we want to match up all the unpaired ones. This is what we were doing with our activity in class. So there's my Na, here's my Cl, and this is going to come over here. Now we're going to redraw our new bonded compound with the dots and appropriate charges. So when Na loses that electron, it becomes positive. There it is. And I've got Cl. Remember, brackets go around the nonmetal. It's gaining. It gained 1, so it has a negative charge. And you can put a negative 1 if you want, or you can just write the negative and positive if it's 1. Okay, let's just do a couple of these just to remember what we had done. K is plus. F has got 7. And there's KF. Let's do Ba. Ba's got 2. Sulfur has got 6. And these are both going to come over here. When Ba gives up 2, it's going to have a +2 charge. And sulfur gained 2. AlBr3. So Al's got 3, and Br has 7. So what's going to happen is we need 3 Brs. So this is going to be times 3, and each Br is going to take 1. So what this is going to look like is this Br gained 1. This Br gained 1. My drawing's getting a little messy. And we're going to put a Br up here. And this Br gained. And Al is left. I'm going to put it right there at the bottom. Not really where I should, but I put the Br at the top. And that's going to be it. All right. Have a great night, and we are going to pick up on our next lesson with drawing Lewis dot diagrams for covalent compounds, which we haven't spent any time on. Just wanted to reinforce that.